your notes. I don't ever grade notes. I don't do anything with notes. It's up to you.
What's the title?
It's up to you. If you can watch, listen, and get it, then watch, listen, and get it. Well, how would you know group 2 is -2?
You know that game?
Miss Law, Destiny.
Wow! That's how you would know that. We did this yesterday. Well, put it on your chart. Those are the oxidation numbers. Remember when we talked about oxidation numbers yesterday? And then we talked about who would and would not need a Roman number? Yeah, that's where that came from. All right, be quiet. Now, to go back and review. Yesterday we talked about group 1 and group 2. So yesterday when the bell rang, we had just finished group 2. How many outer shell electrons did group 2 have in its outer shell?
2.
8.
2.
It's the.
At least I got more 2 answers than I got 3 and 8. All right. Group 2 has how many electrons in their outer shell? We had a whole bunch of things that said S2. All right. And because we had S2, you guys told me there were 2 electrons in the outer shell. And I drew a picture that had magnesium. And on the picture, there were 2 electrons on that outer shell. And we said that we could lose 2 electrons, or we could do what? We can gain how many? 6, because the magic number that all atoms want is how many? 8. So what was easier, losing 2 or gaining 6? Losing 2. And we said if we lost 2, the oxidation number when we lost 2 would be what? When we lose 2, it would be +2, and that's its oxidation number. So if we look back at what we just wrote for Jayla, group 1 has a +1 because it lost 1 electron. Group 2 has a +2 because it lost 2 electrons. Now, today, we need to do 13 to 18.
Yeah, well, I have a question.
Yep.
So, like, why would we, when we do the little ring things, why did we go from 2 to 8?
Huh?
Why did we go from 2 to 8? Is that like the S to the F thing?
Yeah, we don't do D or F because it's never going to be an outer shell.
I'm not talking about whenever you're drawing all of the rings.
Yeah.
Do you just like start that over with S, or do you just keep going and keep adding electrons?
I'm not sure I understand what you mean when you say 2 to 8.
Yeah. Like, so we did the rings, right?
The rest of you who are talking, shut up. The only person I should hear is Nakai.
Like on the first ring, you had the 2. Like,
Yep.
And then the second, you had 8.
Yes, because the second energy level can hold how many sublevels? What are their names? How many electrons are in S? And how many are in P? So 2 + 6 is, that's why it jumps from 2 to 8.
And then you just like keep going up from there, like keep adding.
Yes, because I'm doing something that's in the third period. The first and the second energy level will be full. Remember Aufbau's rule that the whole first ring and the whole second ring had to be full before we could put something in the third ring. I could have done something on the first and second energy level. I'm just choosing to do something in the third period so we have an atom that's got some electrons in it.
So and when you do that, you'll never stop at DNF?
No, it'll never stop on DRF.
Okay.
Okay. All right. So if we take something in group 13, and I'm just going to write 1 electron configuration this time.
Wait, what's the, you've written 1 electron, 2 electrons in the outer shell. How many outer shell electrons?
What would it be if I wrote aluminum and we have 1s2, 2s2, 2p6, 3s2, 3p1? What's the highest energy level?
6.
Okay, 3s and 3p. All right. So how many electrons are in the outer shell? 3. Now, everybody would follow this same pattern. Even if I wrote, let's just say I do a second one. Just to
So I write
illustrate.
that with proof 13 through
Yeah.
electrons.
So if I did G8, and I'm going to do it in shorthand because I don't want to write a ton here. All right, argon 4s2, and this illustrates what Nikaya was asking me also. All right, so here's something that has a D. Will it be the outer shell? No.
Why
Okay.
can't we leave it? You said it once, but I forgot why.
Because the outer shell will have a maximum of how many electrons?
8.
8. And a D could have, like in this case, would have how many electrons? 10. So we can't be an outer shell. All right, so again, what's the outer shell in gallium?
4.
Coefficients are what? There you go. You always look here to tell the outer shell, and 4 is a bigger coefficient, so that's my outer shell. Okay? So, again, there's 3 electrons. So, in group 13, how many outer shell electrons are there going to be? 3. So, everybody in group 13 has 3 outer shell electrons. Now, without me drawing the model, how could we go about getting to the magic number of 8?
You want to drop or add?
Okay, how many would we drop?
3.
Okay, so we could lose 3 electrons. It doesn't matter whether we're doing aluminum or gallium. The choices are the same. So you could lose the 3, or how else would we get to the magic number of 8? Or gain the 5. All right, so if I'm an atom and I'm being lazy, what would require the least amount of energy from me? Lose 3. So I'm going to lose 3 because that's easier than gaining 5.
Oh, we're getting close to like having to gain it.
That's right.
And that would be.
Hold that thought. We're getting there. All right. So if I lose 3, what charge am I going to have if I lose 3? That's right. So my oxidation number is a positive 3 because, again, we lost 3. Okay. So anytime we lose electrons, it means we're positive. This is what I was trying to get at yesterday at the end of class. When we lose electrons, you're a positive oxidation number. Yeah?
Maybe I missed some yesterday, I don't know. But I know, about 3S is, 2 and then 3P, 6 plus 2, that whole thingy. So why would we lose 3? Like, just give us.
Because if we have, everybody got what they want? I'm going to draw aluminum real quick.
I have the same questions.
All right. Everybody got what they want off the board?
Did we learn
Nadia,
this
you
the
got
exact
it?
same way yesterday? Because I feel like I would have remembered this on the quiz, but I didn't.
Yep, we did the exact same way.
Wow.
I know. Sometimes it just needs to percolate in our brains. All right, the first ring, aluminum has 13 electrons because its atomic number is 13. So on the first ring, S sublevel can hold 2 electrons. All right, the second ring can have an S and a P sublevel, so S and P can hold how many electrons?
8.
So I'm going to draw 8. That's where that magic number of 8 comes from.
So S and P go on the same ring?
Now, there's 10 electrons. How many do I need on the third ring? 3. All right, so I want 8 electrons, right? So the question is, how do I get 8? Can I lose 3 or gain 8? I'm sorry, 5 to get to that magic number of 8. What would be easier, losing the 3 or gaining 5?
Then that'd be 10. What?
Okay. If I 3 plus 5, I can lose 3 or gain 5. 3 plus 5 is what?
You're not talking about the 13 as total.
No. We're just talking about the outer shell. So I already have 3 here, right?
Yeah.
There's 3 there. So I can either lose these 3, okay? Or I can gain 5 because 5 plus 3 would give me 8. Okay? So what's easier in an atom's world? Finding 5 more or getting rid of the 3 it has?
I thought we was looking at. Yeah.
Okay? So how is losing 3 going to get us 8? Is that the question?
Yeah. I was going.
Okay.
Yeah.
So if I get rid of 3,
That's the other shell.
now the new outer shell We'll get there in just a second, but yes. That's our new outer shell. And how many electrons are now in the outer shell?
And, okay, I think, yeah.
It's supposed to be 8 in the outer.
Yes. So when I give those 3 electrons to someone else, now I have 8 electrons in the outer shell. This is where our next topic of bonding is coming from. So aluminum is going to give 3 electrons to another element that needs or wants electrons. Okay? Because there are other elements out there who want electrons. Aluminum needs to give them away, so it gets 8. And there are other elements out there who want electrons.
Will there ever be a situation where if you lose the 3 or however many, that there won't be 8 on the inside?
They'll share so that they get 8. But yes, and there are times when they have more than 8. They have expanded octets, and we'll get to that too. All right, everybody with me now? Yes.
In the notes you placed group 3, where did you group 13?
Did I write 3? I thought I wrote 13 up there.
Oh, I wrote 3.
Okay. I try to be very careful about that.
I was disagreeing.
She might not have written chalcogens on her periodic table too. Check that.
I did write it. It's right there.
Okay. Next question.
Why didn't you want me to say it?
What?
She said, are you staying ever? Is that ever going to end?
This one needs a break as well. Look at this.
You ate all my food Monday.
I ate 1 bag of pretzels.
That Caleb called dog biscuits, if I recall.
Yeah.
That's what they look like. And the little pink things you got. Where you get that in the trash. No, nobody eat that.
Savannah
ate them, and Caleb came to my defense and said they weren't bad, didn't you, Caleb? Thank you.
Yeah, gross. I'm just confused. I'm just trying to learn and get better. You don't want to. Oh, I don't want to do
All right.
this.
Then don't write it. I already said you don't have to. All right, so group 14. All right, if we write carbon.
This is when we're going to have to lose some, isn't it?
Hold on.
Why didn't you just?
I mean, gain some.
Or you can do either.
What were you going to say, Cecilia?
Oh, never mind.
Go ahead.
So I saw what I did.
Unless you like.
All right. So, how many electrons does carbon have in its outer shell? What is carbon's outer shell? Let me start there. Okay. So it has how many?
4.
All right. And what's the outer shell for silicon?
3s and 3p.
Okay. So how many outer electrons does it have?
4.
All right. So everybody in group 14 has 4 electrons in its outer shell. Now, I'm going to point out something Cecilia said a minute ago. She said, Ms. Wall, did you write group 3 at the top of that? Now, on the multiple choice test on Friday, would I have an answer choice that said group 3 instead of group 13?
Yes.
Yes, I would. So make sure when you're picking, if I ask this group number, you don't get confused with the number of outer shell electrons and go, oh, it's got 4 outer shell electrons. It's in group 4. Where is group 4?
All the way to the left.
It's all the way to the left of the transition elements, okay? It says group 14, and group 14 has 4 outer shell electrons. So don't make that mistake. Because, yes, I would put that as group 4 on the test, trying to trip you up.
Well, you like the mismatches of science.
No.
Okay? Just saying, I would do that. So, if you have 4 outer shell electrons, what do you have to do to get to 8?
You can do either thing.
That's exactly right. Okay? You can either lose 4 electrons or you can gain 4. Because who's to say which is easier? So, if we can't decide which one's easier, what oxidation number do we have? That's right. Okay? So, since we don't know which one's easier, the oxidation number is plus or minus 4. Okay? The oxidation number is plus or minus 4. Okay? We don't need it, I don't think.
Well, it just goes on my notes and give me a second to read it off.
No. At this point, we should be recognizing the pattern.
At this point,
I can't recognize
I remember.
Why what? Alright. So if we do group 15.
Yeah.
Alright, how many outer shell electrons does it have? Okay. So this time we have 5 electrons in the outer shell.
Right.
So what will its options be to get to the magic number of 8? It can lose how many?
5 or gain 3.
Okay, it can lose all 5
Or gain
or it could gain 3. Now, again, electrons do what's easiest. It always goes with the smallest number. So which number is smaller?
3.
That's right, the 3. So this time, rather than losing all 5, it's going to gain 3. So what oxidation number are we going to have if we gain 3? Okay, so when you gain electrons, you have a negative oxidation number. So we're going to have a negative 3 this time. Then use a hall pass and go to the bathroom. Okay.
Those are extra credit.
I really hate being penalized for going to that.
Okay. I was just offering you an opportunity.
That's not fair.
We are. Oh, let's go.
Possibly. If not today, it'll be tomorrow. If it's not today, it will be tomorrow.
Applying the quantum number. Yeah, you can go back to
What are we doing tomorrow?
Test review.
Well, where do these electrons gaining their
Another atom. It leads into bonding.
Okay, I'm about to say.
All right, group 15, 16.
Look at you, just wow.
And this is the same thing over and over. Do we have to write down?
So, how many electrons will group 16 have?
6.
Okay, so there are 6 electrons in the outer shell. See, this time I'm not even writing an electron configuration. So, if you have 6 electrons in the outer shell, all right, what are the choices? Okay, so we can either lose all 6 or we can gain 2. What is easier? Right. So what oxidation number will we have? Are you with me? I know some of you are. Some of you are still struggling.
No.
Okay.
Boy.
All right. Have I waited long enough, or do I need to keep waiting?
Just wait till we can leave.
No,
right.
take a
Group 17. I can't play Kahoot till we've applied the quantum numbers because half of it's application. All right, so what does group 17 have?
7 electrons.
All right, so there's 7 electrons in the outer shell.
Lose or gain 1.
So it can do what?
Lose or gain 1.
It can lose how many? Or it can gain 1. So what's easiest?
Well, so gain 1.
Gain 1. So what's his oxidation number? So while some of you are writing that, because I know you want your notes complete, what's going to happen when we get to group 18?
It's going to be 0.
Why is it going to be 0?
Because there's 8 electrons.
So what's it going to do when it has 8 electrons?
Okay.
Nothing. It's not going to lose or gain anything.
She's gonna have her best one.
I don't want to lose or gain anything right now. Actually, I would have gained a lot more points in my pre-calc grade. Yes.
What'd you get that up to? You passed?
Yeah, I passed.
Oh, good. Good.
But
I wish my day was higher than this.
barely. Ceci, I'm praying for your grade right now, so I need you to clutch.
You said you had all A's and B's. So why are you complaining?
Who?
I'm complaining.
Hey,
Me, because they're barely A's. Like,
Because it really A's and A's and A. Just like a win is a win and a loss is a loss, and I lost. So therefore, a win is a win.
that's true. At this point, an A is an A. There's no difference between A plus A or A minus anymore.
I'm sorry.
It's an A and it's an A. All right, so 8 outer shell electrons. So we know it will not gain or lose. Now, the last thing we need to finish with is who is the most and least reactive. And the way I tend to do that is to draw the periodic table because it tends to make it easier for visual people. You ain't got to. You have to put 0. All right, does everybody have what they need off the board?
Yes, let's go to the next quantum numbers. Let's do Sitka.
I told you, Coop may not happen today.
that means you should push the test back if we don't get to review.
Right.
The test is Friday.
We're having reviewing tomorrow.
We will review part of the period. We will do new stuff for part of the period too. Whether Annabelle wants to do new stuff or not.
We're not doing this stuff. I'm gonna race it off the agenda. What kind of periodic table is that? For my husband's dad.
Oh, shut up.
You forgot.
For my husband's dad.
It's
What happened?
Right. One in the branch development.
All right, how many electrons are group 1's outer shell?
1.
In group 2?
2.
Group 13?
3.
14? 15? 16? 17? And 8. All right, now, tell me what we just said about what will happen in order to reach an octet. Octet means 8 electrons in the outer shell. All right, so what will group 1 do to get to that magic number of 8? It will lose 1 electron. What will group 2 do? What will group 13 do? What will group 14 do?
Slash. No slash.
I could have, I just wrote or. All right, what will group 15 do? Gain 3. What will group 16 do? What will group 17 do? Rosanna, hush. And what will group 18 do?
Nothing.
Do nothing. All right. Now, from what you just told me comes the oxidation numbers. If you lose 1, what's the oxidation number? +1. If you lose 2, what's the oxidation number? If you lose 3, the oxidation number is. If you lose or gain, it is. If you gain 3, it is. Gain 2. Gain 1. And if you do nothing. Okay? That's a summary of what we've done in the last, I don't know, 15, 20 minutes and yesterday.
Oh my God, my camera not.
I don't know what to tell you about your camera.
Just well, go get in it and say cheese.
No. Fat people don't look good. Now, from that, we need to figure out who is the most and least reactive on those groups.
Noble gases.
The noble gases are what?
Not reactive.
All right, not reactive. All right, they're the least reactive. I like that answer. So let me find another color up here. All right, the noble gases are not reactive. They are stable. Okay, they have 8 electrons. They don't wish to react with anybody.
Right.
They have managed to get 3 of them to react with fluorine, but the other 3, helium, argon, and neon, have never reacted with any of the elements. They've changed the names since I've been in school simply because they have gotten them to react with fluorine, but I don't think they've reacted with anyone other than fluorine.
Which elements have reacted?
All right, so they've changed them from the name inert gases into noble gases. All right, now, who would be the most reactive of the elements? Who? Alkali, and who else?
So plus or minus.
Plus or minus 4. No, the one beside noble gases.
What's the name of the one beside the noble gas? All right. So these are the most reactive metals, and these are the most reactive non-metals.
Whoa, slow down, whoa.
Now, why are these two groups, and I'm going to change the setting on this so that Caleb can see it because I'm going to write something at the bottom.
Right. What is that?
Okay, it says most reactive metals, most reactive non-metals. All right, why are those two groups going to be the most reactive?
Plus 1.
They are one electron away from, there you go, one electron away from 8. The closer you are to 8, the more reactive you are. So group 1 needs to lose 1, and group 17 needs to gain 1. They're the ones that I affectionately refer to as the hosts. Group 1 will give it away to anyone. Group 17 will take it from anyone. They're not picky. Okay? Now, based on that rationale, who would be...
Sorry.
I just said yes.
The
The closer you are to 8, the more reactive you are. Not reactive, it's stable.
Miss Wall, keep it there. I'm going to just write on it. I can't draw for you.
Now, based on that, who would then be the next most reactive? Group 2 and group 16. So it generally goes from the outside to the inside. So where would the most stable metals be on the periodic table? The transitions are the most stable metals. Okay? There are your most stable metals. Okay?
So I'd be in the most reactive.
This side.
Say what?
Not mental at all.
I'd be in the most reactive. So no crazy.
I would agree with that.
This ball would be in the stable.
Not reactive.
The noble gases.
Will you ever need to know the oxidation numbers of the transition elements? No, because they're going to have to give you the oxidation numbers either by giving you a formula where you can average crisscross, or they're going to give you the Roman number so that you know what crisscross is. Okay, you're not going to have to know, for example, that iron could be a +2 and a +3, or copper could be a +1 and a +2. You're not going to need to know that. Okay? All right, now let's see what you guys can do on your own.
I think it's easy.
Which ball? Small space.
Yeah, that's fine. Dr. J, yay!
This is what you guys can do with your brain.
It's fine.
For some of us, it's going to be a paltry amount. That is true.
And then in the second period,
Miss Wall, you go ahead.
Yeah,
second period, I learned that.
I can't even understand that.
Well, I can see perfectly fine without them. It's just.
I can tell by the number of pictures you take of the board and write your notes down that you can see perfectly fine without them.
Well, I can't see far away, and I'm not. When I wake up, I'm not looking far away. I'm looking low.
I need sometimes. Hey, Miss Wall, that's just how it be. Sometimes we'll be like, wait, I forgot my glasses. You about to walk out the door.
Okay.
And you see that.
I can see that.
And then you realize, Miss Wall, take off your glasses.
Why?
I don't see how you can without glasses.
I look the same.
You don't.
Yes, I do.
You don't look the same.
Wow.
No, don't turn around and just.
What?
Absolutely not.
What? What? What?
Anyway.
All right.
Or electrons.
Is that right?
So if we question 44. Alright? I want y'all to do question 44. Now, before I let you loose with this, for people who don't read, what does the first line say? It has to be a second period element, which means you're limited to lithium through neon. Okay? It has to be lithium through neon. Okay? You cannot pick silicon because silicon is not in the second period. I know, that's why I'm telling you that. Alright? Now, I don't want to hear from you. I want you to take 5 minutes and try to answer A through G on your own.
No.
Yes.
No.
I'm not going to let you struggle long. They only give you about 4 minutes. But I want you to try on your own, with your own brain cells.
We don't have any.
Try, Annabelle. What am I here for? To provide moral support?
Yes. Cold. Carbon. So where am I looking?
Second period.
Well, we only got to the break right now.
Say what?
No.
Yes.
Second period.
All right.
Almost lost me.
What?
Okay.
I meant to like.
4.
Actually,
Oh, okay.
Maybe. I don't know. That's supposed to be some of the Keep it like C. It's like over this.
You try.
So there's a piece of wood. Contains 2 electrons. I don't know, dot. What about C?
It's not that hard.
Yeah, no,
Okay.
What is the outer shell here? That's the outer shell electrons.
Octet, I just said meant 8.
The drawing.
I knew that.
Until you listen. Where's what? We need some peas while you're sitting here.
tell you the groups and families.
Miss Wall, is E a certain answer or can it be multiple?
One answer.
It's one
Oh, I
answer.
don't know.
Laura, oh wait, you're.
No, that means that's how it's going to be.
Genius.
I just know what it's saying.
And the other carbon for C.
And that's all.
Wait,
No. Why are you touching my hair?
My math test was easier than this.
So what do you say?
Look at me.
Right?
What is it? See, that's 4. So we're supposed to like.
That's right.
That's scary. My mom got them 3 when they
All right. Who has a total of 4 electrons?
B-E. I was right. B-E. I know it's B-E. It's that B-E boy, whatever.
Why?
Barium.
Beryllium.
Beryllium.
All right. Now, what does a total of 4 electrons mean?
You just count.
Say that again, Destiny.
There we go. You get smart.
That's wrong.
Here I was worried that it was strangling you over there. Apparently, it's holding in those brain cells so they can't leak out. Okay. All right. Total electrons is a top. I'm going there. Hang on. I'm getting there. That's question B. All right. Total electrons is the atomic number. So when it says a total of 4 electrons, it's asking you for the atomic number. So who has an atomic number of 4?
Beryllium.
Beryllium. All right. Now tell me about B. Who has a total of 5 electrons in the highest main energy level?
Boy.
All right. So I hear nitrogen. Do we agree?
Yeah.
You should. What does highest main energy level mean?
Why would it still be outer shell?
It means outer shell. Okay? Highest main energy level means outer shell. So,
What? Yeah, can you explain how?
1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons. Nitrogen is 5 electrons in the second
I
period.
did the E dash, I thought I said -5.
Okay.
Shut up.
But
Yeah, that makes a lot more sense.
okay, I get it now. Tired of this.
Okay. C contains a total of 2 electrons in the P sublevel. All right. Where is the P sublevel? Can we agree this is P?
Yes.
This is P1,
B2.
P2, P3, P4, P5, and P6. That is, the whole column is P1. The whole column is P2, P3, P4, P5, and P6. It doesn't matter what period you're in. Okay? So, we just happen to be in the second period doing this. So, count across. P1, P2. What element is in the second period and is P2? That's how you get the answer. Okay? D contains 3 half-filled p orbitals. What is a filled p orbital? What's half? So what element is half? Nitrogen. Okay? What did we learn dots were the other day? Outer shells. And this one tells me we need how many dots? 3 dots. So outer shells again. If I put them back up here. 1 electron, 2 electrons, 3 electrons, 4 electrons, 5 electrons, and I'm going to stop because we've passed what we need. All right, where would 3 dots be? 3 electrons is here, so what element do we have? Boron.
Is that the answer to E?
That is the oxidation number to E. Yes, that's 3 dots is dot symbol.
What was it?
B, boron. All right. I would venture to guess 25 questions on the test are like this. Okay?
25.
Fortunately, the rest of the page is practicing the same thing. This is why we're not doing Kahoot yet. Kahoot is like this. Okay? It's not gross memorization. It could be, but it's not because this is the way I designed the Kahoot. Most of the ones we play are mine, not ones that are in Kahoot already. All right, F contains 6 electrons in its dot symbol. Again, dots are what?
Outer shell.
So what's the outer shell? Oxygen is correct. Now, if you were listening to me a while ago, I used the word octet, and I told you it had how many? 8. 8 is filled. So who would be in the second period that's filled and has 8? Neon. All right, you with me? All right, now we're going to do question 45. I'm going to give you a little more time. I need to make one correction. Look at C. All right, I did not give you an element in C, and I need to tell you the element. It says the number of occupied energy levels is blank, but I didn't give you an element. So write of chlorine at the end in C. All right, the number of occupied energy levels is blank of chlorine. Now, this does not limit you to a period. This is the entire periodic table. Some of the questions are not about the periodic table. For example, A is just asking you about an S sublevel, okay? So it's going to intermingle some old stuff and the periodic table. We're doing A through O, all right? I'm going to give you no longer than 1125, no longer than. If I hear you just talking, we're done, all right? Your behavior today determines whether we review tomorrow. I'm done. I'm ready to test. The test is copied and ready to go. We're getting in a very bad habit of we're just going to socialize. I don't need the review. We will probably not finish the curriculum. So if I can gain days by skipping test review, I'm all good with that. Okay?
The curriculum,
right? I finished the curriculum, I think, twice in my entire career. All right, 28 years. Yeah.
Curriculum.
So, I'm just telling you, we got a little extra time this year. We got a better chance. So, my point is, if you want test review time tomorrow, don't waste my time now. Do your work and don't socialize. Yeah, be glad to. Okay? Find me some answers. And I'm not just glued here with Annabelle. So if you have a question, just tell me and I'll come to you or you can come to me. She is a little high maintenance, but I'll be glad to help other people too. While I munch on my peas and gross out between her and the kayak. Huh? What? I don't think so. I gotta look. I need to buy some. I'll put it on my grocery list this weekend.
Yeah.
It's a, here, I know you're not finished.
I didn't even know. That's the kind you want?
Yes.
I couldn't like that kind of thing.
It wasn't the whole thing, it was like this much.
Oh, now I got to tell you.
Just like
Just me.
Oh, yeah, yeah.
Is what I got.
we're just looking at.
How many blocks were you have?
It's really not complicated. It's not my.
Wait, that's 7. She just said that the
You're the one you fill in SPD out.
What's up?
Sure. I think it's 3, 2. I mean, 1, 2.
When you say occupied energy levels, what do you mean?
And that's all S, the purple.
How many arrows can you put on the public block?
That's not that second word.
That's what they're asking. So if we're counting across, how many lines, elements do we have somewhere? Another way to go. Yes, sir. Yeah.
I mean, later.
It's not grammatically correct. I just want you to do the question with point. Yeah, Kyle.
What do you mean when you say the full number of occupied energy levels? You mean like how many are full?
How many have electrons in them? They don't have to be full like have 8, just how many have arrows or electrons in them.
Okay.
This is what you got.
So second.
I'll put the questions on that.
The number is
That's what I said.
Yeah.
So the first one. So
Wait, I don't know if we're doing the.
2 2 2.
Find all the twos
So
in
it's
there.
gonna be,
They should go up here, which would be.
I got all the elements.
because they got 6 electrons, what's the three? I don't know.
It doesn't work.
Sorry, I know. That's what I think, but you
Just
know.
count everything that has the two on it. If I said 4, count everything that's 4.
And the electron dot is gonna be out.
There's one more. Here, here, and here, and there. Virginia got fucked. Right, configuration.
Like 6
I got energy level of coefficient. So you'd have to write the configuration of the
Oh, yes.
They up there living their best life.
It's not impossible.
Because you need to know how to figure it out on the test.
No, I wouldn't be
Highest energy level. They don't remember the period.
I just want me there, so. I'll be a drill
They don't remember the highest energy level in the period. You see it? Y'all working over there?
I had to do this. Well, I'm almost done.
Yeah.
No, I would not be.
I'll figure it out for it.
Rosanna, you done?
It's 15.
Not yet, I'm on day.
Right.
Hey, 4, 3rd, into the track. Rosanna, are you on 8?
I got 10 on
What did you look at? The 3rd? Okay.
What is it?
They are.
What is the configuration thing? Aren't they gonna go with the same? Isn't that like the 3SP? Yeah. So it'd just be the 3SP.
I just assumed it was.
Is that? I'm like.
What's a what?
ADC.
Yeah.
Look at your jar of things. It'd be 2.
Everything after the noble gas is what they're asking for.
If you're on the 30.
So when you write the configuration, Rosanna, it's just wanting after the brackets.
Okay.
Oh, no, I heard orbitals out of S equals 5.
Does it E just argue it?
You've already added that. I said that.
Oh, that's about 4.
This one up here, this one up here. So it'd be 7. 2 plus 2. 2 plus 6 is 16. Plus this is 26. 18.
You already added 2. You just did 2 plus 6.
Oh,
And that's the 2 right there. That's the only 2 you need. What the
Because I asked you to draw shorthand, basically write what's happening.
What I'll put on here. Alright, I did it, so now what I do?
It's asking you
I
how
wish I put
many,
18 at like didn't start to sound like this.
orbitals are, basically how many lines.
That are filled?
It does not say filled, it just says contained.
Okay, 5. So it is 5.
We're just guessing.
No, that's how many pictures are in there.
How many energy levels are there in chlorine? So if you write the configuration, all right, how many energy levels do you have? How many coefficients?
Yeah, go ahead, see It was 5, 1 times 3, and then 5 for S, and you tell me there.
You can't say 5. Because arsenic is gonna have a lot more than 5.
Arsenic won't have some of S. Or won't have the same thing as S.
You don't have to go all the way to 6. You wrote it down the other day. It says 1 layer for S. 1 S there, 1 layer. It's contains blank unpaired talking about if it has 1 pair and S pair, that means you have 4 left. Means you have 4. Let's see if we can draw it out.
So what?
Periods of dots.
No.
15.
Yep.
He said what? Girl, we ain't even done that shit.
I'm struggling too.
The number of electrons.
That means 8. And so it's gotta be over there.
And then plus 10 and 26.
All right, let's take a look at what you came up with.
Look, because, yeah, we stopped at,
Where's my question? Yes, ma'am. Yes?
Well,
Yes?
can Raquel come up to the front?
Can who?
Raquel?
Yes. All right, if we look at question A, what's the maximum number of electrons that the S sublevel can hold?
2.
Now, if you get stuck with this, I'm on board. All right, if I get rid of this for a minute. All right, where's the S sublevel? Right here, right? S1, S2. All you gotta do is count the blocks. 1, 2. Okay? All right. Maybe we need to do it a little bigger here. Oops, that's a little
I
small.
thought she said how
All right. Question number 2. A full main second energy level contains?
6.
It's 8. Now, you could have said
Did it say total?
n equals 2. You could have said 2n squared. It said 2 squared is 4 times 2 is 8. You could have said n equals 2 has 2 sublevels. So you'd have 2s and 2p and added them up. Or, here's another method.
Wait, what are you talking about?
8.
Now, where are your 2's at on the chart?
The second one.
Count them
How many
down.
2's do we have here?
2.
How many 2s do we have here?
6.
2 plus 6 is?
8.
Could you do the same thing with 4? If that equals 4, you guys know to do 2n squared or add up your sublevels. Or you can simply look and say, where are my 4s? Here, here, here,
What is that?
and here. 2 plus 10 plus 6 plus 14 is 32.
Look at this.
You can do it that way also. Okay? It's just a different method than what we've been using. Okay? All right. C. The number of occupied energy levels of chlorine. All right. All right. What are energy levels in that configuration?
3.
Energy levels are the coefficients. So 1, 2, 2, 3, 3. So which energy levels are occupied?
3.
1, 2, and 3. So the highest occupied energy level is which one? 3. 3 is the highest occupied. Now, you want a shortcut? What period is chlorine in?
3.
That's the highest occupied energy level.
Wow.
Oh, that makes
Is that
sense.
really?
Works for everything.
I was on
Now, you don't have to use it. I'm just telling you a shortcut you can use. If you forget on the test, go back to the electron configuration. If you remember it, use the period. All right, D, the electron dot symbol for aluminum has how many dots? 3. There's 3 outer shell electrons. There's 3 dots. In E, the third period element with an octet. Argon. Octet means what again? 8. 8 is an octet, like octagon, octopus. All right, so 8 would be argon. All right, F, the number of electrons in the electron dot symbol for sulfur is 6. 6 outer shell electrons. The outer shell energy configuration for magnesium. All right, so magnesium basically we want to write in shorthand. So if I put in the numbers, what's the noble gas in front of magnesium? So Ne in brackets. From neon back over here, we have what number? And then what block? And then how many?
2.
All right, so just leave off the neon. And what do you have left? 3s2 is all they want. All right, so from there, H, a full third period contains how many electrons?
18.
Count your 3s. We have 2 here. We have 10 here. We have 6 here. So 2 plus 10 is 12, plus 6 more is 18.
Oh,
Count the 3s that are on the chart.
we said 18?
18.
The third and
An orbital notation of sulfur contains how many unpaired electrons? 2. Now, you can do the whole notation. I would only do shorthand myself. So we have neon, 3s2, 3p4. Now, what do we know about neon and 3s2? Are they going to have anything that's unpaired or are they full? They're full. The only thing that can have anything unpaired is 3p4. So that's all I'd look at. How are those 4 electrons going to look? 3 ups and then 1 what? So how many of those are unpaired?
2.
That's what they wanted to know for anybody who didn't know that one. Okay? Among the elements, the one with 5 dots. All right? Be is here, so it would have how many dots? 2. Carbon is here, so it would have 4. Fluorine is here, so it would have 7. Phosphorus is here, so it would have 5. So that would be the answer. All right. K, among the sublevels that cannot exist. So find the one on the periodic table that doesn't exist. Does 1s exist? Yes. Does 2p exist? Yes. Does 3p exist? Does 2d exist?
No.
That's the answer. All right. The element that contains a single 4s electron. So 4s is right here. So it would be K. Everybody good with that? Okay. The number of inner shell electrons in an atom of P. This was like in the opening. You could. All right. So you could say it had 15 total. Subtract the 5 on the outer shell and get 10. Nothing wrong with that.
Or you can count everything that's not on that.
Yep. Or you could say 1s2, 2s2, 2p6, 3s2, 3p3, and count everything that's not on that level, like Micaiah said. That's the outer shell. So this is the inner shell, and you'd have 2 plus 2 plus 6, which is 10.
You can do that on the chart too.
Yep. You can do it on the chart too. Anything is fine. All right. Multiple ways to do that. The number of electron containing orbitals in fluorine. What do you need to do there? If they want to know the number of orbitals that contain electrons. What was the easiest thing to do? But most of you did. Did you not get that far?
Wait, what?
I don't know how to do it. Yeah.
It only has 9 electrons. So the easiest thing to do is to draw it. Okay? You got 1s, 2s, 2p. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, how many electron-containing orbitals? What are the orbitals in that?
3. I mean,
What represents the orbitals?
The line.
The lines. So, how many contain electrons? 5. This is 1 orbital, 2 orbitals, 3 orbitals, 4 orbitals, 5 orbitals. There are 5 lines that contain electrons. Okay? Because this one contains an electron. The question didn't say they had to be full. It said it had to contain an electron. So there are 5 lines that contain electrons there. If it had said full, there would only be 4. That's correct. Okay?
Wait, don't do nothing.
Okay. I'll leave it. All right. And the last one is just like one we've already previously done. How many unpaired electrons are there in arsenic? 3. Arsenic is AR 4s2 3d10 4p3. So what's the only thing that's not full? The 4p, right? So again, you have 4p, 1, 2, 3, 1, 2, and 3. So those 3 are not paired.
Just counted wrong.
You could, yeah. Questions? Because you got homework tonight.
oh,
Yes.
This is
is it graded?
Would I check it? Very possibly. Yeah, I'm gonna make my handy helper here hand it out. Now, number 13 on this paper. Number 13, and both sides what Annabelle's handing you.
You said what? I got tell him the name.
Both sides of what Annabelle's handing you.
what did you say about
I might have to schedule another day.
Yes, I suppose. I'm not staying long.
Yeah.
4:15 tops tomorrow.
That's perfect.
You'll be getting what I.
Not staying any 4:45 like I have the last 2 days.
Uh-huh.
You made her stay that long?
I didn't. I was gone at 4:30.
13 on this sheet?
13 on the apply quantum numbers.
Everybody get one? This ball, it was both sides of that.
Both sides. Thank you, my dear. Now,